A helium balloon loses half its size in just 12 hours, but an air balloon can last for weeks. You fill a balloon with helium and it floats to the ceiling. By morning, it is sagging halfway to the floor. Within 2 days, it is a wrinkled lump on the ground. But if you fill that same balloon with regular air, it stays inflated for weeks. The difference is not a manufacturing defect. It is physics at the atomic level. Helium atoms are so incredibly small that they pass straight through solid rubber. The latex is not leaking. The atoms are escaping through gaps between the polymer chains that make up the rubber itself. This is called diffusion, and it happens because helium has an atomic radius of just 31 picometers, making it one of the smallest atoms in the universe. Nitrogen molecules from air are nearly 4 times larger and cannot slip through those same gaps. Latex rubber looks solid to the naked eye, but at the molecular level, it is full of gaps. Rubber is made of long polymer chains, specifically polyisoprene molecules that are tangled together like a plate of spaghetti. These chains are held together by chemical bonds created during vulcanization, the process that turns liquid latex into stretchy solid rubber. But the chains do not form a perfect seal. There are microscopic spaces between them, roughly 1 to 10 nanometers wide. For comparison, a single helium atom is 0.062 nanometers across. That is like a tennis ball trying to block a doorway that is 100 meters wide. When you inflate a balloon, you stretch the latex thinner, which actually makes these gaps even larger. The more you inflate it, the faster the gas escapes. This is why overinflated balloons deflate faster than partially inflated ones. Helium is the second smallest element on the periodic table. Each atom has an atomic radius of just 31 picometers. It is a noble gas, meaning it exists as single atoms, not bonded into molecules. Nitrogen, which makes up 78% of the air we breathe, forms molecules of 2 atoms bonded together. Each nitrogen molecule has an effective diameter of about 364 picometers, nearly 12 times wider than a helium atom. Oxygen molecules are similar in size at 346 picometers. Because of this massive size difference, helium atoms move through the polymer gaps in latex roughly 3 times faster than oxygen and about 5 times faster than nitrogen. A helium balloon loses about 1% of its gas every single hour. An air-filled balloon loses less than 1% per day. The math is simple. The same balloon that goes flat in 12 hours with helium would stay inflated for over 4 weeks with air. The process behind this is called Graham's law of diffusion. It states that the rate of gas diffusion is inversely proportional to the square root of its molecular mass. Helium has a molecular mass of 4. Nitrogen has a molecular mass of 28. Plug those numbers in, and helium diffuses 2.6 times faster than nitrogen through any given barrier. But in practice, the difference is even more dramatic because of how the polymer chains interact with different sized particles. Temperature also plays a role. In warm conditions, polymer chains vibrate more and create larger gaps. A balloon at 30 degrees Celsius deflates noticeably faster than one at 10 degrees. Humidity matters too. Water vapor can soften the latex and increase permeability. This is why outdoor party balloons in summer heat rarely last past the afternoon. Understanding gas diffusion has real-world consequences beyond party decorations. Weather balloons are filled with helium and designed to rise to altitudes of 30 kilometers before bursting. They use thicker latex or synthetic materials to slow diffusion enough to complete their 2-hour flight. Mylar balloons, the shiny foil ones, use a metallic barrier layer that reduces helium loss by over 90%. A mylar balloon can stay inflated for 2 to 3 weeks compared to just 12 hours for latex. In industrial settings, helium leak testing exploits this exact property. Engineers pressurize equipment with helium and use mass spectrometers to detect where atoms escape, finding leaks far too small for any other method. The same physics that kills your birthday balloons is used to ensure spacecraft and nuclear reactors are perfectly sealed. If you found this fascinating, subscribe to Curious Science for more answers to the questions hiding in everyday things.